What's up, amigos? Today we have the aerodynamics of a mini apple pie. So it's one that you buy out of a packet and you can consume it on your way home. And I took a bite out of it just to simulate it. This is a 3D scan, by the way. And it's really interesting that that bite sort of makes the apple pie itself act kind of like a vortex generator. Now, let me explain. So these streamlines show where the flow is moving, obviously. And you can see in the bite where the flow goes up, it goes into it, and then it like bounces up. But then the flow around the edges of the bite stay a lot closer to the actual surface. So what that means is you're going to be getting roll-ups of flow on each side, and they're going to be counter-rotating vortices. And we see that in the wake as well, where you look behind these blue little bits of the streamlines, you see they're rotating in different directions. So this bite itself actually resulted in the little pie becoming effectively a vortex generator. So you can make a vortex generator out of pretty much anything. As for the rest of the flow, like around the edges, it stays fairly well attached. I mean, the flow sort of zips in and takes up the wake section quite well, but it still has a little bit of flow separation. So let's move on to the next video. And now we have the Z-plane going through the little pie. And we can see again, as I mentioned, the wake is fairly small behind, even though it is such a cylindrical shape. For a cylindrical shape, you usually expect there to be a much greater wake. But I think because of the bite taken out of the front, that the wake has been reduced a lot. And that's because, so vortex generators, they produce vortices, as we know. And vortices, they not only mix high momentum fluid into near the boundary layer, near the boundary, but they also just mix up the flow in general. So that's what I think is happening here. Instead of having the wake being very large, the vortices themselves, they're just pulling in flow from elsewhere and making it flow into these low pressure regions more easily, and that's why the wake is becoming smaller. Also, this apple pie had like this cross-hatching kind of shape on top, and if you can see the pressure being plotted on the top, and you can see that the parts that are protruding, they actually have a higher pressure than the little valleys, and that's probably because the flow just probably accelerating over the top. I think that's why they're getting, and then inside the valleys, the flow sort of stagnant a little bit. That's why I think there's a difference in those pressure regions there. And the U velocity, you can see in the valleys, it's very low, and as you get higher and higher, it becomes a bit faster. So that's cool. And now these animated streamlines kind of show what I was saying before, where the vortices that are produced from the bite, where as soon as they get downstream, they start mixing in the flow quite well. You can see these little blue streamlines downstream. They are very chaotic. They're not streamlined at all. And that's because they're just twirling around and they're forcing fluid from elsewhere into this gap in the wake area. And that makes the wake smaller. Interestingly, on top of the apple pie, there are a few little streamlines going the opposite direction. And that's probably because of these ridges. So there may even be something like a laminar separation bubble. I don't know. That's quite interesting. I think I may need to buy another apple pie and do another experiment on it. So that's the end of the simulation. Make sure to like and subscribe and check out the Atmosphere Hawk. It's an instrument that makes your experiments 2 to 4% more accurate on any given day. It also makes your CFD more accurate because your validation is more accurate. Link in the description. And peace out, amigos.